9.5 Medical Applications Using Radioactivity. Radioisotopes have short half-lives and are used in nuclear medicine because they have the same chemistry in the body as the non-radioactive atoms. And in the organs of the body, they give off radiation that exposes a photographic plate scan, giving an image of an organ. So you will notice as we look at the different medical applications of some common radioisotopes that we have, first of all, we notice that the half-life is short, okay? And look at all these different items that can be tested and detected by using the different radioactive isotopes. After a radioisotope is ingested by the patient, the radiologist determines the level and the location of the radioactivity emitted by the radioisotope. The scanner moves slowly over the organ where the radioisotope is absorbed. The gamma rays emitted from the radioisotope can be used to expose the photographic plate, giving a scan of the organ. So notice here, if we're looking at this particular item, a scanner is used to detect radiation from a radioisotope that has accumulated in an organ. A scan of the thyroid shows the accumulation of the radioactive iodine-131 in the thyroid. And you go, well, why did they pick that one? Well, because the certain radioactive isotopes do have some really specific places where they target. So you're going to have different ones for different issues. Now, some of you may have heard of a PET scan, or some of you may know of somebody who's had a PET scan, or maybe you've had a PET scan. Well, you now know, finally, what PET stands for. Positron. And you thought you would never use the word positron again after that, one of those sections where we were learning about positrons. No, you're going to probably have a PET scan sometime in your life, and you can tell the person scanning you, I actually know what the P stands for. Anyway, so positron emitters with short half-lives can be used to study brain function, metabolism, and blood flow. These include carbon-11, oxygen-15, nitrogen-13, and fluorine-18. They combine with electrons after emission to produce the gamma rays, which are then detected by computers, creating a 3D image of the organ. So these PET scans of the brain show a normal brain on the left and a brain affected by Alzheimer's disease on the right.